Hi, I'm Drew, Application Engineer with Baker Instruments. In this video, we're going to be covering RIC testing with the Baker DX. So the first thing you need is your DX has to be equipped with the RLC functionality, which is a special card installed. We'll need to hook up our low voltage resistance leads to the tester. And of course, we'll need to hook up our low voltage resistance leads to the motor under test. Okay. And now we need to select our resistance option. So from the resistance screen, or RLC options, we need to select the type of test, and we want to select the RIC icon, which is a three-phase AC sine waves here on the right. If you don't see that icon, that means that RIC hasn't been activated on your tester, but we can activate that. That's just an upgrade module that you can purchase, and our service department would be happy to install that for you. Okay, so now we just select that icon, and we'll go into RIC mode here. And what RIC testing is going to do, RIC stands for rotor influence check, and it's going to evaluate the influence from the rotor magnetic field on the stator readings that we measure with the resistance and inductance measurement capability of the DX. So we'll position the rotor. In this case, we want to make sure we're at some zero reference. I have a nice 0 degree indication there. On your rotor, you want to make sure you've either marked something, so you either use the keyway or put some mark on there so you know where you're starting from. And then you're going to advance in certain degree increments that you set up in your initial settings. So for me, it's been 10 degrees. So the first thing we'll do once we had our 0 set is push the push to test button. And the tester will go ahead and go through all the different measurements it needs for resistance, AC, inductance, phase angle, and impedance. And once that's complete, you'll see our test line will indicate here, and we'll have a degree 10 there. So we're going to advance our rotor 10 degrees. So go to the rotor, advance it 10 degrees, press the push to test button again, and it'll take our second measurement. So you can see the first reading there was at 0, then the red line indicates where we are now at 10 degrees. And maybe, I don't know if you can pick it out, but there's like little dots there in the 0 index. In this case for inductance, A, B, and C. And now there's our second reading. Okay, and now it's telling us to advance to 20 degrees. So we'll do that. 20 degrees. Push the test button again. Now for some reason during a test, if you make a mistake, you can always go back and reperform another test over the last test you performed. And that's what these arrows here allow you to do. They'll allow you to index through the different positions, either for indication or to go back and reperform a test over the existing test that you took erroneously. Okay, so at this point we just need to follow the degree indications, going to 30 now. Pushing the test button again to initiate the test. And as you can see, the waves, each of these markers were connecting with a line, red for A phase, blue for B phase, and green for C phase. And as we're adding new points, you can see that this pattern is starting to emerge that looks like the icon for the three-phase AC sine wave. And this is the ideal pattern that we're looking for. Okay, it says 40, so we'll advance the rotor to 40. Push the test button again. Okay, and so what this three-phase AC sine wave pattern means is that my air gap flux is perfectly symmetrical, and it's influencing the stator readings in just the right way. If I had some problem with my air gap magnetic field, if there was some kind of asymmetry, some irregularity, it would throw this three-phase AC sine wave pattern off. So now it says go to 50. Now we're at 50. Push to test again. Okay, so if I had a broken bar, for example, there might be a significant dip in that waveform. If I had some kind of static eccentricity, I would see some offset in one or two of the phases. And if I had dynamic eccentricity, all three of the sine waves would have an overall sinusoidal pattern. Okay, rotating it to 60 now. Push to test. Okay. So you can see it's a little blocky. If I wanted more resolution, I could lower the degree increments. So I could lower it as low as 2. The settings are 2, 5, 10, 15. And again, as I have it set up for 10 right now. So if you wanted more resolutions, you can set up a lower degree count, but of course it would take you longer. You'd have that many more readings to take. Okay, advancing to 70, pushing the test. Waveform is looking really good. So depending on the number of poles in your rotor, will kind of define how far you'll have to rotate the rotor to get a full AC sine wave. So that's the key, really. We want to, wherever we start, we want the sine wave to come back to that starting position. That means we've cycled that magnetic field through an entire set of poles. So now it's telling me to go to degree 80. Push the test again. And so in this case, we have a 4-pole motor, and I only have to rotate the rotor through 90 degrees of rotation to get that full AC sine wave. If it were a 2-pole, I'd have to cycle through at least half, 180 degrees. Okay, and then the final position, 90 degrees for this 4-pole motor will get us completed. Push the test again. Now you don't have to stop there. If there was just some question or you wanted to continue the test, you feel free to continue to rotate through. But it's as if we're reperforming a certain section of the test again. All right, so this is our final step. And you can see we returned to where we started from. Our waveform looks very sinusoidal in all 3 phases. There's no significant dips or offset between the phases. There's no overall oscillation of the 3-phase pattern either. If we want to, again, go back and look at a value, you can cycle through the positions. You can see the 3 values for A, B, and C. This is showing you the inductance pattern, which is typically what we use to evaluate the 3-phase nature of the air gap influence. But we can also look at the resistance, AC, the phase angle, or the impedance as well. Okay. So the main thing to remember now that we're complete is to hit that save button. Don't forget to do that. And it's going to ask you if you want to save the active folder and record. That's what I want to do, so I'm going to say yes. Of course, you can add a different record or folder if you'd like. And now the data is saved. If I want to review the data, I can use the report icon here to pull that data up. And just go up here for the reports. And then this is an RLC test. And there you can see the rotor influence graph that we recorded. All right, so that concludes the demonstration of the RIC test on the Baker DX. Again, it's an add-on module that if you don't already have, you can add on later on. Our service department does it all the time. So if you have any questions, feel free to contact technical support. And thanks for watching.